Welcome back, Quadrature fans. My name is Professor Theoremus Antiquitus, also known as Marian Elena. Welcome. Last time we left basically with his notation. Today we're going to cover something fundamental. Fundamental theorem, okay? But let's quickly review. We know that our K-sub-n, the area ratiometric, isoratiometric factor, is 1 over n plus 1. C sub n is n. If you have a curve that's y equals x to the n, an ordinary type curve like x squared, x third, x fourth, something like that, that's called ordinary curve. Okay, and it looks like this. You know, it starts at 0 always, and it just kind of blows up, and wherever you are, that's the box, and there's its diagonal, and these are box operators. And you know how that works. It's just S is our signed area box operator, operates on x to the n, which means that you take x to the n multiplied by 1x, so it raises it by power, and multiplied by k sub n. 1 over n. The tangent slope, that's another box operator. You see that d of x to the n, that's what that means. And that's simply an operation. Take x to the n divided by x multiplied by c to the n, which is n. Or lower it by 1 power. You can already see that the slope increases by 1 degree and the the area increases by 1 degree, the tangent slope decreases by 1. So they are already inverse, they're opposite, and that's kind of where we're headed in this fundamental theorem. Let's look at an example. For example, what if we said signed area of x to the third? What is that? Well, that's simply x to the fourth over 4. Okay, that's nice. And what if we said, okay, now take the slope of that. Here's a function. It returned another function. So what if we say, okay, now give me the slope function, the d function. So d of whatever we have right here of x to the fourth over 4. What is that? Well, crank it through here. That equals, it's basically 1/4, right? Pick up the 1/4 times, here's the 4, x to the third, and lower it by 1 power. And so 4 cancels 4, so that equals x to the third. Notice that you end up with the original function. So here, the area, S, brought it up, you raised it by 1 power, but also the constant invariant itself. Okay, so it was 1/4. Now you take the tangent slope of this thing, including that 1/4 that you see here, and it will essentially cancel out and bring you back to what you started with, x to the third. Pretty nice. And suppose we did d of x to the fourth, right? The slope of an x to the fourth function. Well, that equals 4 times x to the third. Okay? And so now do the opposite. Do the signed area of this function. So we got s of 4x to the third. Well, that equals 4 times x to the fourth over 4. See, you gotta do this. And that 4 cancels the 4 on the bottom, and you end up with x to the 4. So we started out with x to the 4th, and we end up with x to the 4th. So the two functions completely cancel each other out. You end up with the original function. So it's an inverse operator. These box operators are inverses. And we can actually prove that it's not just for x to the 3rd or 4. Let's prove it for x to the n. All right, let's do it. So if we say s of the d of x to the n, see that? All right, what is that? That equals s of, well, it's n times x to the n minus 1, right? We've lowered it by 1 degree and multiplied by c sub n, which is n. Now, keep going further. So what's this? So this equals n times, now check this out. When we do the area, we have to now raise it. So you got n minus 1. So what happens? You add 1, it becomes x to the n, right? Because you got n minus 1 plus 1, that cancels out. So you get back to x to the n. Over n. You have to do this n minus 1 plus 1 on the bottom. So it's just, well, n minus 1 plus 1. Well, that's just n. Okay, so we can already see n cancels n, so you end up with x to the n. So here, your original function, you took the slope of it, the slope operator, a box operator, that gives you another function called nx, n minus 1. Now take the signed area of that, and you end up with the original function. Pretty cool. Let's do the same, but invert the order. Now let's do the d, the tangent slope of the signed area of x to the n. Well, that equals d of, what is that? X to the n plus 1. You raise by 1 power and you divide by n plus 1. Okay. Keep going. You got n plus 1 on the bottom here. Okay. 1 over n plus 1, right? Times, what's this going to be? Well, here, x to the n plus 1, you got to lower it by 1, so it will come x to the n, right? And also, we need to multiply it by this factor, n plus 1, right? That's part of the, when you do the derivative. And so again, we see that n plus 1 cancels n plus 1, so you end up with x to the n, the same function. So these two operators, these box operators, are complete inverses of one another. You do something to one, then you can totally undo it and you get back to what you started out with. And that is a fundamental theorem of what?
Quadrature.
Absolutely. Of quadrature, right? Also abbreviated as FTQ, right? That's it. What else could it be? I mean, that's 1640 technology, so it has to be quadrature. Okay, well, there you have it. Pretty simple. So, anyways, remember what Theoremus Antiquitus would say. Before there was calculus, there was
Quadrature.
Got it.